Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding the flow through pipes in series, or you can say the flow through compound of pipes. So when the fluid is flowing, a number of pipes which is connected in series connection, and what will be the head loss during that flow. So we'll discuss regarding this. So for that, here I have taken a figure. The diagram shows that a tank is there. So this is a tank, and which is situated within particular head, and these are the number of pipes which is connected to the tank. Suppose this is the tank which contains some kind of fluid here, or then the liquid which, the fluid which is present in this tank, that is flowing through this pipe. Okay, now this is one pipe which is connected to the tank, and again one more pipe is connected here. Okay, so here we can see one more pipe is connected. So all these pipes are connected with different diameters. You can see these are different diameters are there, or maybe different length also will be there. But in the first condition, if you see the pipe which is connected to the tank, so here we can see there, like what are the losses can be considered, that we'll discuss. Okay, so before discussing this one, I'll tell you what are the parameters need to be considered to identify the total head loss for this. So first of all, we know that the pipes in series or pipe in compounds can be defined as that number of pipes of different lengths and different diameters. Different lengths and different diameters will be connected to end. This is one end, so one pipe is connected. This is one pipe end, another pipe is connected. This is second pipe, one more pipe is connected to the end. So it is connected end to end to form a pipeline. Okay, so for that, suppose this is section 1, or this is pipe 1, pipe 2, and this is pipe 3. So let's consider the length of each pipe L1 and L2 and L3. Okay, these are the length of pipe 1, pipe 2, pipe 3. Similarly, for each of the pipes we have the specific diameter also. So for that we can write D1 and D2 and D3. Okay, now this is for L for length, and this is D for your diameter. Along with this, we can also write what are the velocities during this pipe. So V1, similarly V2, this is V3. This is of velocity. Okay, this is velocity. Next, what we can consider? F1, F2, F3. So these are the coefficient of friction in the pipe. F1, F2 and F3 are the coefficient of friction. Coefficient of friction. Okay, now this is for pipe 1, this is for pipe 2, this is for pipe 3. Three different pipes, and these are the parameters are there. Okay, and the H is the, we can consider, let right here, the capital H is the difference of water level in two different tanks. So this is tank 1 and this is tank 2. So the difference between these two tanks level, that is H. So we can write this one. So this is the difference of water level, difference in water level in two different tanks. Okay, so these are the parameters what we supposed to consider. I have taken that one. So now we'll see what is the discharge, or you can say the discharge passing through the each pipe. Okay, which is the same. So we can write, we know the continuity formula, like the discharge formula we can say. So that is nothing but Q equal to, we can write A1 V1 equal to A2 V2 equal to A3 V3. So discharge will be same for all these pipes, because what is the quantity of water is coming with respect to time through this pipe, that will be equal to all that points. So that's why area, velocity. So area less, velocity more, area more, velocity less. So that will be different. Now we can find out what is the difference in liquid surface level, okay, and the total loss of head, okay, when there is two different height is there and through these pipe connections are there. So what is the total head loss in the pipe? So that we can write H equal to, that will write total H equal to. So now see, this is the entry point. This is the entry point of pipe 1 and exit point from this tank. So entry to the pipe what? At this level. So during the entry to the pipe, what are the losses are there? That will also come under the minor losses. So minor losses for this, we know that the formula is 0.5 V1 square by 2G. This is one. Next is what? Next, this is a pipe. So during the pipe flow, we need to consider some losses of due to the friction in the pipe, due to the surface friction, the surface roughness and the pipe and the flow between this surface and the liquid, we have the friction. So due to the friction, we have the formula of major losses, that will come under the major loss. So we can write this one. We know that 4F1 L1 V1 square by 2 D1 G. Okay. Next is, you can see, this is the now here this is one different diameter, again the diameter reduced. That means there is a contraction in the pipe. So this is about the, you can say, contraction in the pipe. So due to the contraction in the pipe, this is the major loss, we can say, due to the friction, and contraction is coming under the minor loss, we know that. So here we can write, this is also similar formula will be there, like 0.5 V2 square by 2G, contraction of the pipe. Next, again if you come to this one, the second pipe, here also there is a pipe flow is there, and there is the length of pipe. So that also we need to consider the major losses in this. This is the major loss. This one is the major loss, and this point is the contraction point, that is minor loss. This is major loss, and this is the entry. This point is entry, due to the entry in the pipe, the flow entry in the pipe. Next is what? This one. So this one we can write again same thing, like 4F2 L2 length V2 square by 2 D2 G, again plus. Now again see, this pipe what was there, now again suddenly it was expanded. So expansion happened, expansion in the pipe. Okay. So there again we can write the equation. For this one, equation was there, like V2, now what is the velocity here, coming velocity, and after expansion what is the velocity. So that is V2, the incoming velocity from this pipe 2 to 3, and the velocity after expansion, that is V3, so square by, again here 2G. Now again one more pipe is there, V3, that velocity in the pipe 3. So here also we'll find out we can get the major loss. All this pipe flow which is there, that we need to consider the major loss. And when the extension or expansion, contraction, entry, exist, here you can get the exist in the pipe. Okay. So all these minor losses need to be considered. So for again similarly here we can write 4F3 L3 V3 square by 2 D3 G. And finally this is exist from the pipe. So exist from the pipe also similar thing, very simple. This is what the velocity was there, so that velocity square by 2G. Okay, so this is the total head loss during the pipe flow when the pipes are connected in series connection. So this equation we can give a equation 1. Now if you consider, now see all these losses also you can identify, these are the losses of their individual positions, individual concepts are there. So I'll highlight this, this is minor loss, this is minor loss, this is also minor loss, this is also minor loss. Okay, entry, exist 2, here contraction, and this is expansion here, contraction and expansion here. So if you neglect these minor losses, if you neglect all these minor losses, then what will be the major losses will be there? So the major losses we can write in this way, like H equal to just 4F1 L1 V1 square by 2 D1G plus similarly 4F2 L2 V2 square by 2 D2G. Next, third one, this is 4F3 L3 V3 square by 2 D3G. Now at this point you can see our length may be different. So length we cannot keep the same one. Even velocity also will be different based on the diameter. If diameters are different, then yeah, our velocity will be also different. So we cannot keep the velocity and length both are same. So length gone, velocity gone, diameter gone. Remaining is G is constant, F. Now if the friction, coefficient of friction, because all are pipes only. So now if you consider that F1 equal to F2 equal to F3. Okay, this all are same means then we can write what? Finally, we can write this is the equation. Now we can take common of this 4F by 2G. 4F by 2G, if we take common from that, then what will be there? Length, velocity and diameter plus L2 V2 square by D2. Similarly, L3 V3 square by D3. So this is our equation 2. Now in this equation, what we can see or what we can get from there, the total head loss are basically depend upon the length, velocity and diameter. So what is the length in the pipe, what is the diameter or what is the area, okay, and what is the velocity. So diameter, length and velocity, these are the most crucial things in the head loss, and this is for the major loss. When the questions will be asked the total loss with including major and minor, this equation is given by including of major and minor. So this is minor loss also there plus major loss also there. When the questions will be given to derive the equation for the flow through a pipe in series or flow through compound pipes, and we need to consider the major loss as well as the minor loss, then we need to derive in such cases. Or just we can write individual one part, like this is the portion is there when the water is coming from a tank to a pipe, and this is the entry point as I written here. So due to the entry in the pipe, due to flow through a pipe which is entry to the pipe, in that there will be minor losses will be there. So I already discussed about the minor losses of variety types, so you can follow the previous videos. And like when the entry will be there, what is the losses need to be considered. When contraction is there, what is the losses need to be considered. And when expansion is there, this point is expansion, pipe expansion is there, so what is the losses is there. And from the pipe, when it is existing from the pipe, what is the losses need to be considered. Similarly, 3 major losses are there because 3 pipe lengths are there. This is 1, this is 2, this is 3. So we need to consider the major losses. So major losses used to happen due to the friction, and that need to be calculated by the Darcy-Weber's equation. That also we have derived previously, and these are the other losses. So I hope you understand this theory. It's a quite simple one. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.